All right, here we go. Stephen Banker says, hi, guys. Question about time. Is it possible to measure a length of time shorter than the steposecond or zeptosecond? Zeptosecond. I can't say it. Zeptosecond. Okay. If so, can we measure infinitely small spans of time? How would we have ever gotten to the point in time if there were possibly an infinite number of moments between the Big Bang and now? Wow, this guy, I love you, man, because you...
Okay, there's a little bit of Zeno's paradox in there, which is not a thing.
And this dude smokes weed, okay? I'm telling you, Stephen Banker, that's a weed question right there. That's a weed question.
Okay, all right. I didn't know that's a category of question. So...
I love it.
Couple of points there.
Right.
There's something called the Planck length.
Okay.
The Planck length is the smallest unit of space within which no laws of physics have any meaning, okay? So in quantum physics, space is quantized by these little units of space.
Okay.
Okay? So the time it takes light to cross a Planck length, it seems to me would be the shortest unit of time because there's nothing that can take place inside of a Planck length.
Ooh, lovely.
Because that is the pixels of life.
So it's like you're traveling in between the actual pixels that make up the picture itself.
Yes, yes. So you go pixel to pixel,
right,
but there's nothing in the pixel for you. Right? Because a pixel is just, there's no more detail there for you.
Got it.
Okay? So that would be the shortest unit of time possible. Anything shorter than that, I don't know that you could measure it, nor would there be anything there to measure.
Right. So there's no medium there.
No, nothing.
There's nothing there to for you to put any kind of ruler up to and say, this is where we are, this is where we're going.
Correct. Because there's units smaller than that have no meaning.
Right. Doesn't make a difference.
In the quantum universe.
In the quantum universe, it has no...
By the way, general relativity requires space be continuous and not quantized. If you want to marry general relativity and quantum physics, you need somebody's got to be there for the ceremony, for the shotgun marriage. Because the shotgun marriage was taking place in the early universe, because quantum physics is the physics of the small, general relativity is the large-scale universe. When the universe was small, there's quantum phenomenon influencing the entire universe. Because the universe at one time was small. Okay, so let's say you could divide time infinitely small. Zeno's paradox is, you know Zeno's paradox?
I don't.
You don't know Zeno's paradox? Okay, you have a destination. Well, you got to travel half that far. Now, with what's left over, you got to travel half that far. What's that? You got to travel half that far.
Are we there yet?
You got to travel half that far. Okay,
right.
You keep doing this.
You're never getting there.
Never getting there.
You're never ever going to get there.
But you end up getting there.
Right.
So that's Zeno's paradox.
Exactly.
Okay, so we would learn how to solve this mathematically. It's because the sum of those halves, even though there's an infinite number of them, they sum to a finite answer in a finite amount of time.
That is dope as hell.
Okay.
That's amazing.
Yeah, so
it's the finite containing the infinite.
Yes. Brilliantly worded.
That's amazing.
Lord nice. Yes, the finite can contain the infinite, and indeed it does.
And it does. That's great.
Yeah. Yeah, so he shouldn't worry about that part of the question.
That part of the question, yeah.